starting with graphing an inequality, y is less than or equal to x plus 2. So we'll graph the boundary using slope-intercept method, and there's some requirements here. If it's equal to, there's a certain way we're going to graph the line. If it's not equal to, if it's less than or greater than, there's a certain way. If it's less than or greater than, we use a dashed line or dotted line. That's how we symbolize. So let's take this. It's in slope-intercept form, if there was an equal sign. I'm going to start on the y-axis at 2, move in the direction of slope, and since there's a 1 in front of here, I put it 1 over 1. So that means I'm going to start at 2 and then move up 1, right 1. I determine whether I'm going to have a solid line or a dashed line. Because it's equal to, I'm going to solidify the line when I connect the points. There's my boundary. The second step is determine where to shade. We have to pick a point somewhere on this grid, not on the boundary, to test. If I get a true statement, that's where I'm going to shade. Then that satisfies this inequality. If I get a false statement, that means, whoop, on the wrong side, I need to shade the other side. You pick a point not on that line and see if it satisfies this inequality. So I'm going to plug in 0 into the y coordinate, 0 into the x coordinate, see if it makes the statement true. And I need to ask myself if it makes the statement true. So, is 0 less than or equal to 2? It sure is. So I see where it's at on my grid, and I need to shade on that side. By the way, you're supposed to be using your color at this point. Color this in. But all of these points satisfy this inequality. Graphing 2x minus y is less than 4. First step is just to graph. Graph your boundary. The old stuff is trying to figure out, well, what is my y-intercept? What is my slope? Or it's in standard form, so I'm going to do the intercept method. If I plug a 0 in for the y-coordinate, it wipes out this term, so 2x equals 4. I'm going to have an x-intercept at 2. When you get an idea of where the line's at, you got to determine, am I solid or dashed? So I got my points, but I make sure my boundary is dashed. That means I'm not including those points on that line. They're not solutions, but either this side or this side of the line make that statement true. In this case, if I pick a point not on that boundary line, the origin is always just nice to use because it wipes out terms. 2 times 0 minus 0, is that going to be less than 4 is the question. It only takes one point to see where you're supposed to shade. If you don't trust it, you could pick another point, maybe on this side. You could pick 1, 1, 1, 2, 1, 3. You could pick negative 1, 3, or 4. You can pick as many points as possible, and it's always going to turn out to be true. But I need to shade on this side of that boundary. I want you to try this one on your own. Negative y greater than or equal to 2x. I'm going to put down the steps of what you're going to do, but I'm not going to fill it in until I see you attempt it. This is where pencil's nice, and then we can color in the right answer later. These are what I need to know. Our boundary line, if I divided both sides by negative 1, by the way, don't forget, if you divide by a negative 1 and you keep that inequality symbol there, it's supposed to flip when you divide by a negative. Now, does that affect our line? No, because when we do a test point, we always go back to the original. But let's talk about the y-intercept. Notice how there's no number over here. So we assume it's like a plus 0. I actually start on the y-axis at 0, and then this is interpreted as negative 2 over 1, down 2, right 1. The boundary has to be determined. Are you going to connect those points with a solid line or a dashed line. Because it's equal to, it's going to be a solid line. I then determine where am I going to shade. I use a test point. Notice how in this example, however, our typical test point 0, 0 is being used. Can't use it to test if it's on the boundary. So you have to pick another point. Is it going to make the statement true? If I plug in a 1 in for the y coordinate, a 1 in for the x coordinate, is -1 greater than or equal to 2? That's the question. I go through the math trying to determine it. -1 is not bigger than 2. It's false, so I am not going to shade on this portion of the line. I have to shade on the other side. Maybe I don't trust my math skills and I pick another point. If I tried 0, 1, I get -1 bigger than or equal to 0. I ask the question. Again, I get a false answer. So it just verifies that, wait, this point is also not supposed to be included. It kind of looks like my line is on it, but it's just a little off there. But I shouldn't be shading on this side. All the solutions are on this side. Let's set up a little table just so we can have a comparison between one-dimension inequality and two-dimension inequality. That's what the symbols could have looked like. Or, one dimension means one variable. What if I had y is less than 5? We always used to deal with x, but we could have dealt with a y. Typically we looked at the sign. If it said less than, I shaded to the left. If it was a greater than, I shaded to the right. So let's, oh wait, did we even use a two-dimensional picture? Not really. I would have a number line at -1, open circle shaded to the left for that first example. If we look at the same symbols, because not always do you need two variables to go in higher dimensions. This is a vertical line. So the slope is necessary. Vertical line would be undefined slope. So when we get to two dimensions, we can talk about slope. Shading, you have to pick a point and figure out what side you're going to shade on. So instead of just like looking at the sign, we may have to pick a test point. So in two dimensions, we have a vertical line at -1, and then I have to pick a test point. If I pick 0, 0, is the x coordinate 0 less than -1? It's a no, so I'm not going to shade where 0 on the side that 0, 0 is on. I'm going to shade on the opposite side. So we can take something one-dimensional and turn it into two. Page 112, numbers 36 through 40. That's literally homework. You do it at your home.